Alright, class, let's take a look at this next problem. It's a number theory question, which often seems simple but really tests our understanding of fundamental definitions. The question says, suppose m is an odd integer greater than 10. What is the remainder when m is divided by 2? Let's break this down together. Okay, let's start with the most important part of the problem, the definition of an odd integer. As you see on the screen, step 1 is to understand this definition. What does it actually mean for a number to be odd? It means that if you try to divide it by 2, it won't divide evenly. There will always be something left over, and that something is what we call the remainder. For any odd number, that remainder is always 1. Now let's express this idea using algebra. This is a very powerful way to represent number properties. As the text shows, we can write any odd integer, which we're calling m, in the general form m equals 2k plus 1. Here, k can be any integer. Think about it. 2k is always an even number because it's a multiple of 2. So if you add 1 to any even number, you are guaranteed to get an odd number. This formula is the algebraic definition of an odd number. So what happens when we divide our algebraic odd number m equals 2k plus 1 by 2? The 2k part divides perfectly by 2, giving us day k. But then we have that plus 1 left over. That's our remainder. So no matter what integer k is, the remainder will always be 1. This confirms our definition from the first step. The theory is solid, but sometimes it helps to test it with a real number. This is a great strategy for SAT problems if you're ever unsure. The problem gives us an extra piece of information. m is greater than 10. Let's use this. We'll pick the simplest possible number that fits the description, the smallest odd integer that is greater than 10. What would that be? That's right, it's 11. Now, let's perform the division as shown on the screen. We are going to divide our chosen number, 11, by 2. When we do the math, 11 divided by 2 is 5, with something left over. As the equation shows, we can write this as 11 equals, open parenthesis, 2 times 5, close parenthesis, plus 1. That, plus 1, at the end is our remainder. Just to be sure, the explanation also shows another example with the number 25. 25 equals 2 times 12, which is 24 plus 1. Again, the remainder is 1. This confirms our rule holds true. So let's bring it all together for our conclusion. We've seen from the definition, from the algebra, and from our examples that any odd number, when divided by 2, will always have a remainder of 1. The part of the question that says m is greater than 10 is what we call extra information. It's there to see if you get distracted, but it doesn't change the fundamental mathematical property of what it means to be an odd number. And so, we arrive at our final answer. The remainder when m is divided by 2 is, and will always be, 1. Great job following the logic on this one. It's a good reminder that sometimes the most direct path to a solution is understanding the core definitions. See you in the next lecture.